realize. Okay, it's Lara, right?
It is Lara.
Lara. All right, Lara. Angular GDE. I had to look that up earlier.
Yes.
Google Developer Expert.
Correct.
That sounds like a hard thing to get.
It's a process.
It's a process.
Yeah.
Okay, it's a process. NX champion. I don't know what NX is, but I'm going to find out
It's
tonight.
a monorepo.
It's a mono repo.
They do monorepo. So like Capital One, for example,
Okay.
uses NX mono repos to just organize their code, and
Okay.
it's a really
All right.
cool. If you don't know about it,
I want to know about it. I'll find it out.
I'll do another whole talk about that.
Okay. And you're a co-host of the Angular Plus show.
Correct.
This is a podcast.
It's a podcast.
Okay.
It's available on anywhere you can get download podcasts. So if you're interested in
Okay.
Angular or like Angular adjacent topics,
Sweet.
it's fun.
Awesome.
We're ridiculous, so yeah.
I love it. Extensive enterprise experience, leading enterprise Angular projects, and you also supposedly bring enthusiasm for software community and continuous learning to every talk.
It's true.
It's gonna be great.
Yeah.
All right, everybody, let's give it up for Laura. See how it goes. All right.
So one.
See, you need to stop sharing.
Oh, do I need? Oh yeah, and then I need to start sharing. Okay, I'm gonna go ahead and share. Whoopsie doodles, I forgot something here.
Maybe look at the thing.
Hello? It's
Okay,
on.
Okay.
I'm like, I thought I did it.
Yeah, I wanted to make sure.
That would be embarrassing. Okay. And then hold up. I gotta actually share.
You gotta switch.
Okay.
Just a sec. We gotta get
Okay.
the people on the Zoom call.
Yeah. So this, for those of you that can see it yet, so if you're on the call, this is my slide deck. Oops, that is not what I wanted to do. I'm so sorry. Okay. This is a link. Okay, hold on. It's not there yet. They're doing it. They're doing it. So fun fact about me, though, is I used to work for Source Allies, and I can confirm it was a great place to work. So definitely hit them up if you're looking for a new opportunity. I'm not even getting paid to say that. So, and this was actually the first place that literally this room was the first talk I ever gave. So it's slightly weird to be back, but good to be back. All right, now you can see it. So this is the slide deck. You don't necessarily need it. I do keep this up to date. It's sort of my ongoing what's going on in Angular talk. And also, there are some links throughout that you may be interested in. There are a few code examples that can sometimes be difficult to see on the screen. So again, he kind of already went through all this. I am a co-host on the Angular Plus show, Angular GDE, NX champion, but I also have 3 courses on the Angular Pluralsight path and a new course on LinkedIn learning about Angular signals. So if you watch those, I do get money, so go do that. If you want to reach out to me, I have abandoned repositories on GitHub that you can go judge me for. I am reachable on LinkedIn, and sometimes I pop into Blue Sky. But mostly those are the ways to reach out to me. So the reason I'm doing this talk is because Angular has a release cadence that is every 6 months. So it's really easy to feel left behind about what's going on in Angular. For those that are here in person, how many of you have used or use Angular? All right, so nobody that's in the virtual audience saw that, but several people did raise their hands. So it just happens to turn out that today version 21 was released. So we're really excited about that. And I will be covering that sort of at the end of this talk about what was released today. So Angular, just to catch people up, is a declarative JavaScript framework. The original release was in 2010. Version 2 was out in 2016. If you're writing Angular version 1, I'm so sorry. It's quite different in the world now, but so 2016, which is the second version, that's how that works. That was when that was released. It is maintained by a dedicated team at Google. It is also used internally at Google. And many people like it because it's a batteries included opinionated framework. I work with a lot of different devs. I like that it gives me some guardrails and helps them not make dumb mistakes. So I am sad to inform you that if you're writing anything before version 16, I consider your code legacy Angular. And legacy Angular has a reputation. Angular has a steep learning curve. You totally lost me with those major breaking changes between version 1 and version 2. There are people that are still very salty about that. Parts of the framework make the developer experience difficult. Modules don't know what you're talking about. And what about performance? So at version 16, we start to transition into what we consider modern Angular. So they updated the logo. So I just said that. Basically, if we look at the Angular roadmap, we can see that they have two main framework goals. The first one is to improve the developer experience, because if you wrote Angular in version 4, you know that it kind of is scary. And also to improve the framework's performance. Because it is batteries included, it's a heavy framework. So how can we make things go faster? To kind of mince that out a little more, we have the goal of simplified architecture, streamlined APIs, improved performance, but very importantly, backwards compatibility. If we look at our road to where we're at today, there were two major landmarks that got us where we are. We had the Ivy compiler was released in version 9, and standalone components were released in version 14. So the Ivy compiler improved performance by enabling ahead of time compilation and tree shaking. And it also opened the door for a lot of what makes modern Angular really great. Standalone architecture was the same thing. It simplified the architecture and improved performance. It also eliminates the need for modules. So if you've ever written Angular and you're like, I don't understand where to put this, what module it goes in, how modules work, you don't have to do that anymore. And it is backwards compatible with modules. So if you're like, no, I love my modules, you'll pry them out of my cold dead hands, you can still use them. The thing that standalone architecture really does, though, is provides better visibility into code boundaries, which means better tree shaking. Standalone true is the default now for components and directives. So if you new up an Angular application, you don't really have to know too much about what's happening to do the bootstrapping. It'll just do it for you, and it happens out of the box. The Angular CLI also provides a migration tool to get to standalone components if you're using an older version of Angular and you want to migrate. Okay, so we talked a little bit, I mentioned backwards compatibility. To promote the idea of backwards compatibility, Angular has a very solid release cadence and also deprecation cycle. So features are introduced first in experimental, then developer preview, and then stable release. They will not make breaking changes to existing APIs unless they have deprecated and then waited a full year for that deprecation cycle. They will also backport improvements when possible. They did this with the optimized image directive. And then the team has been very, very, very good about providing schematics for migrations to some of the more modern syntax. Okay, so experimental features in the docs are going to be clearly marked as experimental. This means they may have been released before an RFC. A lot of times as a GDE, I get early access and they're like, hey, give us feedback, tell us what you think about this. And that's when we're really trying to give the team our opinions on how it's working, if it's working for us, if it's ergonomic, all of that. It's experimentally functional within a framework, but you should be very aware that it's subject to significant breaking changes. Developer preview might have an open RFC, like a public comments. It's going to be fully functional in the framework again, but it's still subject to breaking changes. So you use that in your production code as you're comfortable. Stable release is going to be fully functional within the framework. That RFC period is going to be closed, and it's going to conform to Angular's deprecation and versioning standards. Okay, so if you are interested in what has happened in Angular, there is a completed roadmap list here on their website. I'm going to go through some of the highlights, but this is great to just kind of page through. These are all the features, not all the features, these are a number of the features that are released in stable release and are production ready currently in the framework. And we're going to kind of go through this list, so don't memorize it. And then we've got our developer preview and experimental features. So we have quite a few new features that were released in version 21. Today, for example, everyone's super pumped about signal forms, so we'll talk a little bit more about what that is. Okay, so, but how do these changes affect how you write Angular, right? Because you probably don't, you might care about the deprecation cycle, but you probably care more about how it makes the framework actually work. The first really big one to change how I write Angular was the built-in control flow syntax. So basically, this uses a template syntax with declarative APIs. So this is to be used in place of the structural directives ngIf, ngSwitch, and ngFor. And the nice thing about this is they're available without additional imports. Previously, if you needed to use a structural directive, you either had to import the common module or you had to import the directive itself, either into the module or the standalone component. So these bring optimal, they provide optimal type narrowing, which is better type checking. It exists at build time instead of runtime. And with specifically ngFor, we see significant performance improvements. So previous code, some of you might recognize this, where we've got our ngIf here, we've got our else block, which is for some reason in a template, this always bothered people on my team. Like, why does it have to be ng template? Why can't it also be ng container? It just has, that's the rules, right? Now it looks like this. So we're using the @if, you pass in the condition. The nice thing that this syntax brings is else if. So if you've ever done the thing where you're like ngIf, and then you have to nest another container with another ngIf inside of that, and it starts to get really, really confusing. Now you don't have to do that. You can else if to your heart's content. Then ngSwitch, I always feel like ngSwitch with a structural directive, they're hard to kind of reason through, especially if you're looking through a really long template. This is what it looks like now. So the cases, again, we're kind of going with a more JavaScript feel in the templates, which just makes it easier to kind of reason about. And it provides us an opportunity to provide a default block in the switch case. So that's awesome. ngFor, this one actually doesn't look too bad, right? That's okay. But the problem with this is that people often forgot to put a track by function in there, which meant if you had a lot of data on your page and something changed, you might see flickers in your repeaters. So the for block now makes track mandatory. So basically what this does is it gives Angular a way to understand what element is there. So instead of having to check all the elements inside your for block, it only checks the single affected element. It also provides an empty block. So now instead of saying if my list is empty, give me this empty block, you can just say, here's my list, iterate through it. If it happens to be empty, do this instead. I said some of this already makes the track function mandatory. It builds in that empty block. But the most important part is that it actually uses a new diffing algorithm under the hood, which makes the runtimes up to 90% faster. Don't know why that didn't show up. Oh, yes. OK. So for version 20, ngIf, ngFor, and ngSwitch were deprecated. That means in version 22, they will likely be removed from the framework. Now, that might make your heart like skip a beat a little bit, but you can prepare for their removal in version 22 by using the migration schematic. So if you're in that situation where you happen to be keeping up with versions, but you're still maintaining a lot of templates that are using the old structural directives, you can use the schematic. I can confirm this thing actually works. We have some horrible templates that we had to migrate, and we really didn't have any problems. The main problems we had was fixing our own crappy code because we had so many like nested blocks. It made it confusing. All right, we also get local variable declaration. So the ng container declaration looked like this. A lot of times, for some reason, you'd have to put an ngIf in there, right? Like if I wanted to subscribe to an observable using the async pipe, I had to put it with an ngIf to be able to expose the values out of it. That's annoying because it's not really like that sometimes. So the let declaration now, we can actually subscribe to it here. So this is using a signals implementation. We can also use this with something like the async pipe. So this does the exact same thing as the async pipe with the as, whereas now this let is now user, and you can use it anywhere within the scope of that where that variable is declared. So that's a lot easier. This also gets you around that situation where you have to, like specifically with something where you've checked to see if a property exists, and then you have to like keep checking again and again. I don't know. It happens all the time with signals. It gets us around that, and that makes it a lot easier. Speaking of signals, we have the Signals API. Signals are pretty much every framework except React is doing something with signals right now. And so there's actually an EC39 proposal or TC39 proposal out to add signals as a reactive primitive in JavaScript itself. And that is based on the Angular Signals API. So signals are not a new concept. If you've used Excel spreadsheets, you've used something kind of like signals, right? And where you have some blocks that are sort of data providers, like the number of guests. If we change that, we've got other cells that are affected by those changes. They are represented throughout the JavaScript ecosystem. Angular is really pretty late to the game compared to some of the other frameworks. So why did Angular add signals? It really comes down to the two main goals of the roadmap: improving the developer experience and improving the framework's performance. So on the topic of improved performance, signals allow Angular to complete change detection cycles faster. So let me demonstrate. So you don't have to read all this. I will not read all this to you. This is what happens in a component during a change detection cycle. But it also does all of this stuff because it's got to also run change detection on all the children. Now, that's a lot, right? That's literally a lot to process. So we want it to do that less. What Angular uses is zone-based reactivity right now. So right now it's using Zone.js to check every node on every change detection cycle. So what that means, we'll talk about that here in a second. If you look at a framework like Solid.js, Solid uses fine-grained reactivity. In Solid knows exactly which nodes have changed and only updates those nodes. So it's only re-rendering those DOM nodes. So reactivity is really a spectrum. With default Angular change detection, you're way over in coarse reactivity land. That means that everything that causes a change detection cycle is going to check every component every time. So that looks kind of like this. We're like, hey, something happened. Let's check everything. I'm not sure what happened, so I better go find out, right? It's kind of like I liken it to a clickbait headline where it's like, something happened and you're never going to believe what it was. And you're like, okay, well, I'll read it. And you're like 7 pages in, and it's just like you actually give up before you find out what happened. All right, so that sucks. So we want to move closer to fine-grained reactivity. So we can, even in previous versions, like before version 16, we can implement on-push change detection. Now that is going to detach certain nodes from the change detection tree. So what that looks like here is, hey, something happened. This assumes everything in this tree is on push, by the way. And instead of everything running change detection, it's still going to start at the app root change detection, and it's going to run down through all of the ancestor nodes to get to the affected child node, right? So when something happens, so for example, if this pushes a new value to a stream, like an observable stream, these components, if you're using the async pipe, will be marked for check. They're like, hey, something happened over here. I need you to come look. But it also marks all of the ancestors up to the root for check as well. That's how on-push change detection works in a nutshell. But we can do better. We want to get closer to fine-grained reactivity. So if we use on-push change detection with signals, we see it is more like this, where something happens, and we know that the cart buttons and the cart component are the only ones that care, right? They're the ones that are reading that signal value. So what happens under the hood is when the signal gets a new value, the component marks itself for check, but it marks its ancestors for traversal. So I think I picked a terrible color, so I apologize if you can't see this. I outlined them in purple, and I forgot that some people don't see that very well. So if you can't see it, let me just tell you that this one is outlined, and this one, and this one, and this one, and this one. So when change detection runs, then it'll start in the root still, but it's just going to drive through those components. It's not actually going to do any work. And when it gets to the components that care, then it's going to run change detection and determine what changed in the DOM. So signals don't actually make Angular reactivity fine-grained, but it moves it closer. It gives us a better tool than Zone.js to determine what actually changed in the DOM. We also have our improved developer experience. So really the nice thing about signals is they have a very simple interface. You have a constructor. In this case, Angular uses a factory function to create any of their signals. You have a setter, some way to set the value or initialize the value. You have a getter, some way to read the value. And then under the hood, it does consumer tracking. So under the hood, it builds out a graph of basically there's nodes and the edges between nodes are directional. So they always flow one way, but they never make a cycle, right? So it's a directed acyclic graph, I believe, if I remember right. So that's what's happening under the hood. And then Angular provides push-pull reactivity to be able to read it. Okay. So consumer tracking is what allows Angular to specifically target affected components for change detection. I'm going to elaborate on that just a little bit more. So basically, if you read the value in a signal, you're inside the reactive context for Angular. So Angular knows to say when when a new value comes in, the graph notifies its consumers, I have a new value. Then the template that's reading the value says, hey, I know this thing has a new value. I need to trigger rereading it because signals don't get executed until they're read. And so you have to be told that something changed, but then you have to have a way to read the value out of it. So the reactive context in Angular is templates and effects and like technically computed, but they don't also get read until like they have to be read to execute. We're going to talk about those a little bit more. The biggest mistake I see people make with signals is trying to read the value and expecting reactivity, reading it outside of the reactive context. So, okay. We have like signals basics. We have writable signals, computed signals, and effects. There's more to it we'll cover briefly, but these are like the building blocks of signals. So we can use the signal function to create a new signal that can be read and updated directly. So this looks like to declare a writable signal, just declare value, use the signal factory function, pass it whatever value you want to initialize it with, and it's set up, it's ready to go. If you want to change the value, you invoke the set method. If you need access to the previous value, you can use the update method with a callback. Then you can read the value by invoking the signal. So this is what I use, right? Like this is how I don't actually have to do anything about the dependency graph because I don't need to know it exists, right? That's the nice part about it is the signal kind of abstracts away that responsibility for me. Now, computed signals rely on other signals and they're recalculated when the signals they depend on are updated. So to declare one, you use the computed factory function. It takes a callback. And then you can see here, it's depending on count. So anytime count is updated, it's going to re-execute this callback. They are read-only. So you cannot directly set a computed function. And then you just read the value the same way. So they tried very hard to keep the interface very similar. If it's a signal, you always read it this way. Doesn't matter what kind. Signals can be typed, so you can provide types to them. Computed signals can rely on other computed signals. They can rely on many computed signals. You can kind of build up a whole system and not have to think about it too much. All right, then we have the effect function. So this is going to be basically a signal effect. When it gets a new value, the effect is scheduled to run on the next execution cycle. So effects are tied to the component's life cycle. So when I get a new count value, this callback is going to run and I'll see the count is whatever it is logged in my log. I kind of said that. They're tied to the component life cycle. These have to be declared within the injection context. So you can declare them within the on init hook, you can declare them in the constructor, or if you declare like a field in the class, that also is within the injection context. Now, the problem with signals that you have to be aware of is you can lose values. So in this case, we've got the set timeout that is going to, when it goes off, it's going to quickly set the signal 3 times. But in the console log, we're probably going to just see 3 get output. And that's because it changing schedules it to run, but it doesn't actually cause it to run. So it's just something to be aware of. Now we have some more exciting versions of signals. So like those were released in version 16. You get pretty far with it, but then there are situations where you're like, okay, there's certain things I can't do and I would really like to be able to do it. So the first one is linked signals. I don't know why that first one didn't come up. Okay. These are for variable state that depends on other variable state. And so you declare them by passing a computation function instead of passing a default value. And you use the previous value by separating the source from the computation. That makes no sense without seeing the code. So let's look at it. So in this case, I've created a linked signal. This is the easiest way to declare one. So basically what this is saying is that my selected option is going to be initialized as the first value of the options signal. Now, the example I like to give is if you're building up like a food delivery app, and when the person logs in, they get all the available delivery windows. Well, if they take a long time to pick their food, those delivery windows are going to change over time. And so you don't want them to be able to pick an invalid window. So we need a way to be able to update those options. And that's what linked signals are for. So you can, the nice thing about linked signals, they act like a computed, but you can directly set the value. So they're like a writable computed. And then you read them the same way. Now you can do fancy, where you can set the signal that you want to depend on here. Wait, I'm sorry. Back it up. Don't look at me. That's wrong. This is like an example in code, right? So you've got your shipping options, and then you've got your selected option. And so this is that situation where I'm like, what if these shipping options change after somebody has picked something? Now, if somebody picks something and the options change, their previous state gets lost. But we can make that not happen also. So we can take the source, which is the signal that you're depending on, and separate it using this computation. So I could go in here and say, if the value that is selected by my user still exists, retain that, otherwise set it back to the default value. So it's very handy, especially to build up nice user interfaces. Apparently I put the animations on these really weird, but okay. Next, we have the resource API, because probably the biggest place that we use observables in Angular is getting data. And making HTTP requests, it can be difficult. So the resource API handles asynchronous data for a signals code base. So you can, in theory, write most of your code without any observables. So if you hate observables, you could get away without doing that. I do need to point out that the resource API remains experimental in version 21. It's been out for a couple of versions. They're being extra cautious with it because these asynchronous operations it's really important to get this right. And so they're taking a little extra time. I would say that the interface is, okay, nobody hold me to this, but I would say the interface is fairly stable. I've used it in a ton of demo code, so I hope it doesn't change. The nice thing about the resource API is it has a built-in loading state. You can even easily re-trigger requests by calling reload. So there are 3 different kinds of resources. There's resource. This only handles async requests like promises, right? If you want the special sauce for observables, you need Rx resource. And if you want to make a straight up HTTP request, you can use the HTTP resource, which that just wraps the HTTP client. So this is very handy. All right, so the nice thing is that all the resource types return the exact same type, and this provides a consistent, predictable developer experience. So you always know that, like, if I read the value off of this resource, whether it's an Rx resource or an HTTP resource, it's going to be the same pattern everywhere. If you read the errors, it's the same property that you're reading. All right, so if we're looking at the interface for resource, basically you can pass in parameters, so it can, because you're passing in a signal here under the hood, it's using a computed. So it's actually, I think it's using a linked signal, which uses computed. But so anytime this parameters are going to change, it's going to invoke this loader and go and fetch the things, right? And then you can read the values. Rx resource is almost the same, except for some reason they named it stream, and I hate this, but it's not. It's like that ship may have sailed. I guess I could complain louder. But that's really the only difference. It operates the same way. HTTP resources, like I said, it wraps the HTTP client. The nice thing about these is the requests are eagerly evaluated. So we don't have to wait for the request to return, because once you initialize any resource, it exists. right? The value exists. So you can always read the value property. It just might be undefined. And then as it comes in, as long as you've read it in the reactive context, it'll automatically react to that change. The requests are eagerly evaluated, and I just said that. Okay, HTTP resource can be very simple. So simple that no code is necessary. There we go. I'm like, come on. So you can do something very simple, like just pass it a URL. You don't even have to, if it's going to be the same all the time, you don't have to, like with my pets API, probably that's going to be pretty stable. If something happens where I think it might change, then I can retrigger it in my code. Or you can have it also depend on the value of another signal. So if you've got like your selected pet ID, anytime this changes, it's going to go make a new request for you. Or you can pass in an object that has much more detail to it, right? So you can still do everything that you could do with HTTP client, but now you just do it, you wrap it in HTTP resource. Now, some of you might be saying, does this mean I never have to write observables again? And that means I would say probably not yet, right? And maybe not ever. Observables are asynchronous. They handle every value. So if you're in a situation where you're like, I need to make sure every value gets recorded, you probably still want to use your observables. They're great for HTTP requests, for example. At this point in time, observables are still required in a lot of the router. So route guards, for example, if you try to read a resource in a route guard, that value exists. So it's just going to say, yep, it's undefined. And then your route guard your router continues and goes on. If you give it an observable, it'll actually wait for the request to get made. Like it'll wait for the observable to get a value before it completes and lets you through. I ran into that in my routing course, which is available on Pluralsight. Right. We've got signals are synchronous, but as we saw with the effect, they might lose values. But a lot of times we don't care in the template, right? Like I just want the template to reflect what the state is right now. And I use them all the time in services and components and directives and forms, right? So there's a lot of really great use cases for signals. You can build almost entire applications without, the only time I've had to use observables in any of my demo apps has been dealing with route guards in the router. So how can you start to implement signals in your code today, you ask? It's actually very easy. So if you have a lot of observable code, the biggest benefit you're going to get from signals is at the template level, because then you can start to take advantage of the traversal in the tree. So you can use the toSignal method. It's a RxJS interrupt package. And this basically, it just takes an observable, and as it subscribes to and unsubscribes to it for you, and as you get new values, it updates the value of the signal. You can do the opposite to combine observable and signal-based code. What you don't really want to do is read the value of a signal inside an observable stream and expect that the observable stream will get those new values. It'll literally only get the value that it is when it hits that code, right? Okay. So I told you all this. toSignal only retains the last value. It's not like a replay subject that can hold on to more than one value. It's only going to retain the last value. toObservable converts a signal to an observable. Basically, yeah, so it receives, anytime the signal value changes, it emits a new value into the observable stream. And this is using effect under the hood. So you have to be aware you may actually lose some values with this. So if you're using a signal and it's something you have to make sure gets, like, if it's like clicks of a button or something, might be not your best choice. Okay, but how are they used in Angular components, you ask? I would love to tell you. We have a really great simplified component syntax now. So previously in Angular, we used a lot of decorators. So we use the input decorator, right? And this works fine, right? I've got it's a disabled, yep, if it's not set it to false. To do the exact same thing in using signals, you can use the input function. And this is going to do exactly the same thing, except that now this disabled value is a signal. So it's kind of ready to use. It also will handle if you need it to be required. So you can actually, you can type it, you can make it required. You can also pass in an options object to do other things that you could do with previous decorator syntax. And then we have signal queries. So has anyone had to use viewchild before? And you get the like expression changed after check? Yeah. So the reason that happens is because, you know, like the value may not exist at like, there's a whole life cycle that has to run. If you use view child or view children, there's like two. Basically, you can get rid of using the ng after view init, and so it's nice. You can, because once you declare this, it exists. It just might not have a value yet. Same thing with content children or content child, because there's two of them. It's the same thing. And since they're synchronously declared and they exist once they're declared, you no longer have to do work inside these lifecycle hooks. You can put the same work inside an effect. And so you don't have to figure out which lifecycle hook does it go in? Why isn't it working? Why am I getting this stupid annoying error? All right. Then we have model inputs. So one of the things that brought me to Angular in the first place was two-way binding. And it turns out it's a pain in the ass to do. So model inputs provide a writable signal input. You can bind these to the parent property using signals or plain JavaScript objects, and then you can do implicit change events. So the decorator-based syntax lists something like this. In the child, you had to make an input, and then you also had to make an output. And then in the parent, you would use the banana in a box syntax and bind it to the value of the parent in the parent component, right? Now, this funny thing is that I always forgot is that this is a magic name. It has to be named the exact same as the input with the word change at the end. And if you mess it up, it didn't work. Model inputs are like, we don't like magic. Well, it is magic. It's just working inside and you don't have to like actually perform the magic yourself. So now in the child component, you just declare it as a model. You can do the same banana in a box binding in the parent template. And then in the parent, this can either be a signal or not any other value as well. Okay. Then we also have function-based outputs. These are not signal-based, but they're not decorator-based, and that's cool. They also created a type called output emitter ref, and they fully support observables now, because if you've ever bound an output to an observable, the Angular team did not know how that worked. It just did. Now they know how it works because they made it work. All right, so the decorator syntax was like this. Now we just declare it as an output. You kind of see the pattern that's emerging here, right? Like they're trying to make this easier for us. And then you can also bind it to an actual observable and have better understood functionality with it. And it turns out you can learn more about signals in my LinkedIn course on reactivity and signals in Angular. There's a lot more to it. But in my course, I really do go into a lot more detail. There's also a lot of great free resources out there if you're not inclined to pay for LinkedIn Learning. So now everybody should stretch because we're getting there, y'all. We are getting there. It's just a lot of content. It turns out the Angular team's been like super busy. So I'm going to go for more of the Steve Carell stretching, I think. So another big project for the Angular team has been improving the server-side rendering story in Angular. If anyone has ever used Angular Universal or server-side rendering before like version 16, it's just not good. It's real bad. Like you would do server-side rendering, you'd get the page, and then when the JavaScript showed up, the whole thing would destroy the DOM and then rebuild it. So it was really bad for web vitals and just the bad user experience all in all. But it turns out that server-side rendering can dramatically improve your application core web vitals. Server-side rendering is not for every app. It's one of those things where you're like, do I need server-side rendering? And unless you can come up with a really, really, really good reason why you do, just don't do it. Hydration is when hydration reconciles the server rendered DOM against the interactive browser rendered DOM. So the server can only render HTML and like CSS and stuff, but it doesn't know how to do JavaScript things. It also doesn't know how to do Angular things. So when the two come in, they have to match up exactly, and so that's called hydration. And so like, I can't even remember, maybe it was version 15, they introduced partial like non-destructive hydration. So at the very least, if you did server rendering, it wouldn't destroy the whole DOM the first time it showed up. So that was nice. But we have more that's happening with that now. So out of the box, that the non-destructive hydration is now enabled, but you can actually fine tune it with incremental hydration. We'll get into that a little bit more. They've also added event replay. So if you have server rendered code and you're waiting for your JavaScript to show up and you've got a really eager person that just like spams a button a whole bunch, like you don't want to lose all those button clicks because clearly they wanted to click the button that many times. And so the browser will actually capture those events and replay them back over the component once the hydration event has occurred. It's really easy to add it. You can new it up. And actually the CLI will now ask you if you want server rendered code, or you can add it to an existing application. And then you can add event replay. I think it actually defaults to setting it up for you, but you could take it away if you didn't want it. I said all that. So I'll give you a second, everybody. Okay. One thing I really love that they've worked on and recently moved to stable is route level render modes. So sometimes you might want some of your code to be server rendered and some of it to not be server rendered. You might also want some of it to be static site generation, like if it's static content. So now you can do that at the route level by passing in a render mode. I'll just let you read through those. But basically, it just kind of allows you to fine tune what you need done for which route. So that's very handy. So now we're getting to deferrable views and incremental hydration. This is the stuff that really excites me, specifically deferrable views. So basically, deferrable views allow you to defer the loading of the bundle for certain parts of the template until the loading condition is met. The Angular team supports a series of triggers and prefetching strategies. And then the deferrable views also supply a placeholder, loading, and error block templates, or template blocks. So basically, previous to this, if you wanted to lazy load your code, you had to use the route, right? So that made us do really weird things in the route where we're like, what if I have a secondary route? That's a good idea, right? Like everybody loves maintaining those. Or you'd like nest and nest and nest and nest, and you're like, things are in the route that really don't need to be in the route, but here they are. So we would do creative things like that. We could do view templates. Like there was a sort of a sneaky other way to dynamically load or to lazy load components. But there's a lot of boilerplate to remember with that. And it turns out that lazy loading can really improve your initial page loads. My one app that I worked on, there was this one part of the app that was somehow in the template, like the first page load, and nobody owned it and nobody maintained it. It was gigantic. So we're like, how do we get this thing out of here? Because it was in the initial bundle and it was really, but nobody ever went there. So deferrable views was our answer to that. Deferrable views is actually a key part of the incremental page hydration story. So I'm talking about just code splitting to be like, hey, don't load this yet, like split this off from the initial bundle, only request it when I'm ready for it. You can do the same thing with hydration. So if you've got server rendered code and you're like, you know what, don't even hydrate this part of the page unless somebody requests it or unless it enters the viewport. You can do the same thing with incremental hydration. So you can really start to fine tune when those bundles are actually being requested by the browser. So it only requests code when it's needed. It's not tied to routing. It's tied to other events. And it can improve your core web vitals is what all that says. So this is what a defer block looks like. It follows the same kind of syntax that we saw with the control flow. So you can take, basically in this trigger, it would say it uses the observer intersection API in the browser. So when possible, they use the native browser APIs to determine when to trigger these things. And basically, once this, the element, it's actually when the placeholder enters the viewport, it will then request this bundle. While it's waiting to get that bundle, it loads this loading state. If something happens, it loads the error state. So this is the professional way to say that. The default behavior, you can do it. You don't have to pass in anything. The default behavior is to load when the browser becomes idle. Now, you might say, when is the browser idle? Because it doesn't mean that browser isn't doing anything. It means that the browser thinks it has time to go do something else. And so it's kind of deciding how much load it can carry. And this is, again, doing that same thing where it's going to, once it's triggered, it's going to replace that placeholder content either with the lazy loaded content or the loader, depending if you've declared one. Now, the key thing with lazy loaded content is it has to be standalone. So if you have a lot of module-based code or you have that one like really old code that you want to have go away, you didn't hear it from me, but you can wrap that old module in a standalone component and then lazy load that, right? It just, the two pieces that touch have to be standalone because the standalone components give the builder the visibility to know where to split the code. If the parent is module-based or the child is module-based, it doesn't see the boundary and it doesn't know how to split it. Now we use on conditions to trigger. So on, it's using or conditions. So Angular maintains a list. We've got on idle, viewport, hover, immediate, and timer. There's also never. And never, it's hard to know when to use that, but it does exist. And those I think are fairly self-explanatory, but they're all available and maintained by the Angular team. So if you put in multiple conditions, it's just gonna, whatever one happens first is gonna trigger it. You can also do when. You can use when with your own, you can bring your own expression. So it's something that has to evaluate as a Boolean. You can also combine these with on conditions. So you can like write really fancy conditions to determine when to load that code. And it's also important to remember that like what happens in the defer block stays in the defer block. So like once it's loaded, you can't use it like an if block. It doesn't make it, like it doesn't conditionally load it. It just conditionally requests it. So now incremental hydration conveniently uses all the same trigger conditions that deferred loading uses, but to do it, you just pass it in hydrate. Fancy, right? So then everything you learned about defer blocks before, you can still continue to use. All right. They're a game changer for application performance. We saw huge improvements in this one legacy app we were maintaining when we started to just really split up that code. And then there's zoneless change detection. Remember how I said that Zone.js powers Angular change detection? Well, it turns out it doesn't have to. Zone itself is a very heavy library. There's not to bag on Zone, but it also like Zone does some like monkey patches browser APIs. And so basically when you rely on Zone for your change detection, you don't always get updates that happen in the browser. Like Angular has lagged behind on some of that stuff because of the Zone dependency. So as of today, I'll have a big announcement, but all of the Angular apps at Google have been running on Zoneless, and they've been doing it for several releases. So it is possible to run large Angular applications Zoneless. My app at work runs Zoneless. All of my demo apps that I've built in the last couple of years are Zoneless. As long as you understand on-push change detection, it's not a big deal. Like it just happens to work. The reason we want zoneless is it reduces the number of change detection cycles. If you don't have the overreactive clickbait screaming that something happened all the time, you don't have to go check. It can improve the debugging experience. If you've ever looked at your stack and it's like zone, 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 like I don't care about any of that. I just want to know what happened in my app, right? And then if we don't have to loan Zone.js, we get a smaller initial bundle. And then we get better ecosystem compatibility because we can start to use libraries that don't get messed up because Zone messes them up. You can get ready for zoneless by implementing signals and on-push change detection. According to Minko, if your application is using on-push change detection, it's already ready for zoneless. And that has been our experience, that we've also experienced that. But wait, there's more. It turns out version 21 was released today. So the first thing is that new Angular apps by default do not include Zone.js. So if you're going to make a new app, make sure you understand how on-push change detection works, because you might be surprised when you're like, why isn't anything happening, right? So there's documentation on the Angular website to help you understand what on-push change detection is, like what triggers it, what special things you might need to do about it. Signal forms have been released in in experimental. It's an improved developer experience. I was trying to read all those things together. Everyone is so super excited for signal forms because forms suck every time. It doesn't matter across frameworks. Every single time, I've never enjoyed any experience with forms. So they're really working on that. We're not going to have template driven and reactive forms. Like there's 2 ways to do forms in Angular. Well, good news, guys. Now there's 3. So, and it's a really, it's a very simple interface. So step 1, you're going to create a form model. So you're just going to create an interface. Then you're going to create a signal that matches that interface. Then you're going to go ahead and pass that model to the form factory function. It's going to create your form. You can access fields directly off of the, this should say const in there, but off of the form that you've created. And then in your template, you bind them using the field property, using square brackets to bind it to this dynamic property. Or you can, so the user would then update it by typing, or you can do it programmatically by setting the value, because under the hood, it's a writable signal. So, and then step 4 is read from the form state. So there are ways to read from it. It will also be able, the field state will give you the value, valid or touched, those type of properties that you might need. And then, so like if you're reading the value, you can read it in a template, or you can read it programmatically, right? So there's a lot of like, it's a lot more easy. So if you're interested in learning more about this, there's already some really great content on YouTube from folks in the community that they've been putting out. So it is important to remember they're experimental, but if you are interested in this feature, which if you ever have done Angular forms, you should be interested in this feature, this is the best time to test it out and give feedback. Because once it moves out of experimental and into developer preview, that API starts to get pretty set. So it is great if you have the opportunity to test this stuff out. We also get Angular ARIA. So who loves accessibility? Like we all love it, but who loves doing it? Nobody, right? Like we all want it, but like it's hard. So Angular ARIA is a headless system. So basically that means that you get all the behavior and you bring your own styles to it. So it's supported through the Angular team. It's going to maintain WCAG best practices for commonly used patterns. And future releases are going to be adding additional behavior patterns. So in version 21, they are supporting these patterns. So this covers quite a bit of what we end up doing, what we need to deal with. I love this personally because it is just so hard to know if you're doing accessibility right. And even when you think you've done it right, you find out that it's not right. And then you feel sad because you made somebody's life harder. So yeah, so this is a really big update. VTest is now the default Angular unit test runner. They sneaky threw this in. They were like totally jerking the GDEs around for several months. Like, oh yeah, we're not sure which one we're gonna go with. We're not sure. And it turns out they knew all along, and it's VTest. So I'm excited about this. VTest, like I remember using Jest and thinking like, wow, Jest is so fast. And then finding out that like Jest is kind of bad at some stuff. And VTest obviously is gonna solve all our problems and we'll never need to change again. But it is good. The other nice thing is that the syntax for VTest is very similar to Jest. The main thing you have to be aware of is if you're using Jest, things like jest.mock, like anything that's Jest, you'll need to update to the V version. So, and you can still use Jest, like you don't have to not use it. And you might be saying, what about AI? Because that's all we do now, right? We write AI. It's our whole life. So the Angular CLI makes it really easy to start coding with your preferred AI tools. If you new up an app, it's going to ask you which AI tool you prefer to work with. You can also use the CLI to add this for you. Basically what this does is it adds the Angular best practice files in the place where it needs to go for your AI tool, because you know none of the tools have the exact of course they're doing it different, because they're like, no, I want you to be with me forever, and the way I'm going to make you do that is if you develop your entire best practice system around me. So the nice thing about the AI or the CLI is it'll put it where it belongs for you. And so that's great. And then the Angular team also is maintaining this list, so you can check back regularly. But even better than that, you can use the Angular MCP server. So that was just released. It was actually released in, I think, 20.2, but it's officially in 21. There are several experimental and also stable tools. I've kind of listed them out here. I do include a link to the Angular blog. So if you go to the Angular blog, they kind of go through and write longer descriptions. So, but basically this handles a lot. You can use the best practices guide. It can find all of your Angular projects for you. You can use it to search official documentation. The nice thing about find examples is, so one of the problems with Angular is because it's been around since 2010, a lot of the language models were trained against patterns that we don't do anymore. And so if you don't do anything, it's almost guaranteed it's going to generate you code using structural directives. So this MCP server is going to help your tools find the right patterns to push you more towards using modern Angular and help keep you away from using the older patterns that just aren't as effective. I also love the AI tutor. The AI tutor, you can actually launch an interactive AI-powered tutor. So if you're like, hey, help me learn signal forms, the AI tutor will help you do that. So that's pretty cool too. You can also evaluate your generated code using the Angular CodeGen score. This is open source. The team claims it also works not with Angular. So if you're looking for a pipeline tool that can sort of evaluate the generated code, you should have a look at the CodeGen score. I know that's something that we're concerned with at work. We have a lot of generated code that gets pull requested every day, and it takes a long time to go through some of those pull requests because everything's a little bit different. All right. So you might be thinking, how can I take advantage of the changes in Angular today? And all you need to do is update to the latest version. Simply update your app. I will say that, I know I say that a little bit jokingly because sometimes it is easy to get stuck on a version, and I wholly acknowledge that that is people's reality. If you are stuck, I recommend going to the Angular update docs. They do provide migration assistance to try to understand what you might be getting stuck on. If you're really stuck, Google it, because there are some very generous people in the community who have been very good to say, when I went from 9 to 10, I had this dumb thing I did, and this is what I had to do to fix it. So you maybe don't have to reinvent the wheel, and maybe they can help you move past it. You can use migration tools. They do support a whole suite of migration tools, especially once you get to a higher version, but you want to clean up your code base. It'll go through and do, really, these are all pretty good. I've run into a few where I have to do a little bit of manual tweaking. You know, like you still want to babysit it a little bit, but it does a pretty good job. And the future of Angular is bright, I say. So I do think that I feel like there's a lot of investment at Google in Angular. Angular is heavily invested in AI if that's something that's important to your team. They are invested in helping you use AI tools more efficiently to write better Angular code. And the best way to learn more about any library or framework is to join a community of nerds. I mean enthusiasts. So the Angular community, it's a kind of a smaller community. They're really great people. I know I really haven't, okay, I'm sure there's some jerks out there because there always is. There's always somebody that's going to be a jerk. I haven't met a lot of people that are. The people that are the most vocal in the community are usually very welcoming and happy to answer questions, because in their hearts, they're nerds, right? Like they love Angular and all they want to do is talk about it. So you can, this is Brandon Roberts' starter pack on Blue Sky. That's a great place to get started. The community, there's a lot of community there. There's a lot of community on LinkedIn. You should definitely listen to my podcast. I don't get paid when you listen to my podcast. But that's actually, I was listening to my podcast before I was on it. And so that's very nerdy. And then that's what happens if you listen to it enough, eventually you end up hosting it. There's also an Angular meetup that meets online. And I recommend joining that if you're just kind of looking for a way to get involved in the community. There are programs where you can, if you have, something you figured out about Angular, there's an NX Champions program supported through ngconf where they're happy to, we will review your article and they'll publish it on their blog if you want to get involved that way. There are also ways to learn Angular. Obviously, Pluralsight and LinkedIn Learning have courses that I get paid if you watch. But the angular.dev tutorials are really great. They've gone through and updated a lot of them. It's not just the tour of heroes anymore. They've really taken the time to make a lot of great content and a lot of videos. There's all these AI tools. There's a lot of ways to learn Angular now, and it's easier to learn than it has been before. Again, there's my slide deck. Thank you so much for hanging in there. Now you get to stretch again and go to the bathroom and all that. So thank you. All right. Yes, ask me questions. Google, like I just do Google Slides. But that's because I can bring them with me everywhere I go. Because my biggest fear is that someone's going to steal my laptop on my way to a conference and then I won't have my slide deck. So yeah, yeah. Well, and that's a cool thing, like the Signals API. If you're like, oh, I haven't been able to use Angular Signals. If you use like YouTube or Gmail or anything, you have used it as a consumer because the Wiz team, which is the internal team that writes like Gmail and all those things, they collaborated with Angular to create that API. So Wiz and Angular use the same Signals API. So that's a fun fact. So if you contribute at all to the documentation of the Signals library, you can say that you contributed to like Gmail. So yeah, any other questions? And also, if you're shy and you want to message me a question on like LinkedIn or something, I'm happy to answer there too. Or if I don't know the answer, I'll send you to the person that does. Yeah. I, I think that like Signals forms are really going to be kind of a game changer for that. I hope. Like, to be full disclosure, I have managed to dodge having to write forms in most of my roles. I literally assign those tickets to my teammates, but don't tell them that. So, but I think that's a pain point across the ecosystem. Um, yeah, I think what I really appreciate too is that I appreciate that Google team, like the Angular team, they do really listen to the community. They're approachable people. They care about our pain points. Like they genuinely want to make this framework easier to use. And they also want to make it a better experience for the people that have to use the apps that are written in it. So so yeah, I could go on. If you would like me to stand here and evangelize, I can also do that. Um, so, but yeah. Anybody else? Yeah. Hmm. Nice. Yeah. 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 It's, hmm, yes, pretty much. Yeah, pretty much. Yeah. I mean, there are other things you can do, but like Angular is one of however many JavaScript frameworks. For a while there, we would say, yeah, for a while there, we would say, like every day a new JavaScript framework is, now we just say every day a new AI tool is launched. So, but yeah, you're coming into it. So I was talking on the podcast with one of my friends who were like, oh, this is a great time to learn Angular. It's actually kind of the worst time to learn Angular because we're still kind of like version 16 is not that long ago. And so it is a lot for people to kind of take in, if especially if you're working in an enterprise application that's been around through versions. There's going to be old code. You're going to have to know a little bit about modules. You're going to have to know what a structural directive is. But if you're writing a brand new application, it's pretty easy. And a lot of, especially if you're using, like the Angular MCP, you can get pretty far. The Angular tutor is good at explaining what it's doing. There's a lot of people making content, and that would go for pretty much any JavaScript framework. It just kind of, to me, I think you kind of pick, sometimes you choose what you're going to write because that's what they pay you to do. And sometimes you choose what to write because you're curious and you want to know. And other times you're like, no, this is just my preferred tool. It feels more ergonomic. I'm actively going to seek roles writing this kind of code. And none of those are wrong. So yeah. 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 Ask away. Mhm. Right, right. Yeah. So I would say if you talk to people on the Angular team, they collaborate with other framework authors all the time. Like Ryan Carniato wrote SolidJS. SolidJS is entirely based on signals, fully fine-grained reactivity. Ryan's a great guy. He's really smart. But like they collaborate because I think where we're at, I went to a talk, it was honestly, oh gosh, it was probably like 8 years ago now. How do you pick between React and Angular? Because at one point it was, which one do you pick, React or Angular? And it's like, you're not picking between anything bad. Like if it's something that like there's documentation out there, it's good. You're picking between excellent tools. It's just a matter of which one either people are either you're using at work or you want to try out or you happen to really like. I like Angular when I'm working with a large team because it's opinionated. When people go off the rails with Angular, it tends to be in the same way, right? Like I can show code from my code base where I'm like, look at this. And, obviously I kind of like neutralize it so you can't tell exactly what it is, but the same patterns, like people be like, I thought you were showing my code because that is exactly what our code base looks like. Everyone tends to write bad Angular. And I say bad, and that's judgy. That's not fair, right? Like sometimes we write the best thing we can at that moment, and it just happens to not work very well as that code base continues to grow. But like patterns that are not extensible and not performant tend to evolve the same way in Angular, whereas like something like React can really go in a million directions. And so walking into any Angular project, you kind of have an idea of what to expect because it is very structured. And I don't have a lot of experience. I've had very little experience with Vue. I don't have any experience with like Svelte. When I give talks, if I'm going to talk about JavaScript frameworks, I usually cover React, Vue, Svelte, and Angular. That doesn't mean they're the only ones that exist or the only ones worth looking at. It's just you have to limit yourself because otherwise people will be like, okay. And a lot of them, if you do start to compare them, they're pretty similar. I would suggest going to bolt.new because bolt.new is capable of just spinning up a new application and just kind of pick through it and try to understand, okay, how is this thing bootstrapped? How is it configured? How are they getting, like you can start to see where things are similar and where things are different. Angular is very similar to some frameworks in some ways, and in other ways, it's completely different. Like we have the component decorator on our JavaScript classes, right? Like that's special. We still have to have a selector. They are looking towards selectorless. So if any of you are listening and you're like, will we ever get selectorless Angular? Yes, it's probably happening. It's on the roadmap. But like there's still some things that Angular does that is weird. Zone.js was a big one, and that's been a huge pain point for Angular developers. So getting that out of there is going to be helpful. So yeah, you're not gonna, I think any tool you choose isn't gonna be a bad one. It's also worth looking at the market where you're at and finding out what is getting written there as well. Because you don't want to be like, I'm a SolidJS developer, that's all I'm going to write. And then you find out like, oh, I'm all by myself. So But yeah, it's worth looking into. Like I said, bolt.new is a great place to just kind of start messing around with it, just kind of see how it looks. Do give the same prompt and compare, just see how it looks. So yeah. So okay, I have a whole talk about this. If you think about convergent evolution, right? If you look at things in the ocean, you're going to find a whole bunch of organisms that look like crabs. Not all of them are crabs. It just turns out at the bottom of the ocean, it's advantageous to have legs and giant pinchers, right? And so in JavaScript, if you think about the problems we were trying to solve, now you're probably younger than me. I'm going to go out on a limb and assume that you're younger than me because I was born in the 70s. So but I got to witness there's a few of us in this room that have witnessed the horrors of the internet, where like you can hear the dial-up sound and like you're waiting and like all of the websites looked exactly the same because they were all just HTML. And then like CSS came in and you're like, oh my God, I can make my MySpace page look weird. And it's kind of evolved, like this ecosystem has evolved. And JavaScript frameworks came in because it wasn't easy to make the websites that designers wanted, that companies wanted, and that users expected using the basic tools that we had. So you can do at the end of the day, any JavaScript framework is JavaScript. So you can, in theory, write it all in JavaScript. You just don't want to. And so they all evolved to basically handle change detection, to handle state management, those kinds of, to handle routing, like those kind of situations. So yeah. And it just turns out I think that's one of the things I love about programming is that everybody's going to solve the problem a different way. So yeah. What's, yeah, exactly. And internet speeds got better. And like, yeah, I mean, I remember my first Mac, it had 9 megabytes. I had like a 9 megabyte hard drive. And I was like, oh my God, it's so huge, you guys. So, so yeah, like everything's gotten faster. And then the consequence of that is that people expect things to be better. I mean, like, can you even imagine waiting for like 5 seconds for something to load? I mean, when that happens to me, I'm like, refresh, refresh, refresh. Is my internet down? Like, what's happening? so, so yeah, cool. That's okay. So Angular is a batteries included framework. And so it's going to solve. So like if you write basic React, you can write a hello React world with like very little code, right? But it doesn't have routing. It doesn't have state. I mean, it kind of has state management if you get into like prop drilling and stuff, but like it doesn't do, so Angular kind of abstracts away a lot of that stuff for us. So I don't have to think about routing. I just have to configure it. And so and then sometimes you find out like, hey, we wrote this framework and we built the change detection engine on Zone.js, and it turns out that's been kind of a bad thing for us. It's been a good thing because at the time it was revolutionary, right? Like it was great. Like I could update all the parts of my app at the same time, because if you do that in vanilla JavaScript, it's a giant pain in the butt. But later you might reevaluate and say, hey, this isn't working so well for us anymore. And then the frameworks do go in. It's kind of just like refactoring, like where you've written code and you're like, you know what? I thought that was going to work, but it doesn't work for this. So either I have to figure out how to make it work for this, or I need to refactor it. So yeah, I think that's what you see. And I think that's just how every system works. Java works that way, right? Like, hey, you know what? It'd be great if we could do this. And other languages can do this. And if we could do that, that would make this job easier. And so yeah, it's just an evolving, we're like code is evolving and it's changing. And so yeah. Exactly. Remember when everything was server side rendered and then we're like, let's do everything on the browser. So yeah. And now there's like, it's kind of swinging like it's just like this pendulum that kind of swings. I mean, like signals have been around since the 60s. It's just, we didn't use them. That's not the tool we chose at the time. So yeah. All right. We good? We good? Well, and I encourage you to come to more of the meetings. It's awesome that you're here. I love that everyone took the time to join tonight. This is how you grow and learn, and you know, now you can be sort of opinionated about Angular because you'd be like, yeah, Angular signal. Yeah, so um yeah, signals. So yeah, you could just be like, signals have been around for a long time. Like alrighty, I'm gonna stop sharing. Thank you.